Hello everyone! So today we're going to be solving for derivatives through the long method so we can find instantaneous velocity. Coming right up. So this is my position time graph. It's just an approximate. This is not even the question we're using. I'm just doing it to show you what we're actually doing. We know that the velocity is just the slope of my position time graph. Since this is position versus time, if I can get the slope on this graph, I know how fast this particle or whatever this is that's moving is moving through time. To get my average velocity, all I have to do is pick my 2 points in time where I want to get the average velocity, and I just solve for the slope on that period of time. So I just get my y2, that's the slope equation, over x2 minus x1. So to get the instantaneous velocity, we can try by making this difference in time, this case is here, but then you can try to make it very, very small, so you get an approximate of the instantaneous velocity. If I want to find my instantaneous velocity at 2 seconds, then I can pick my first t to be 2 and my second t to be 2.00001. I get a very good idea of what my instantaneous velocity will be at 2, but it's not actually at 2, it's an average of the velocity between 2 and 2.0001. If we can make that difference, that h difference or change in time, equal to 0, and still solve for my slope equation somehow, I get my instantaneous velocity. So I'm going to make my position formula to be equal to 2t squared minus 2t plus 4. And I'm going to pick my t1 to be equal to just t, and my t2 to be equal to t, like we say, plus that little h, which eventually we want to make this h equal to 0. So now let's start with, that means that we have t plus h minus x of t, which is my top part of the slope, over t plus h, which is my t2, minus, and that's just t1. So we have x prime of t, equals to 2, and then I have t plus h squared minus 2, and then I have t plus h plus 4. All of that I have to minus the same thing again, but just with t. So minus 2 t squared, then minus times minus is just plus. So that's plus 2t, and then again minus 4. All of that, I know, over t plus h minus t. But now we can just delete the t's, because t minus t equals no t's here, so it's only over h. So now we can just expand this. We might need another paper for this, but okay, we'll just go through it. So we have 2t squared plus 2th, right, plus h squared, minus 2t minus 2h, these terms, plus 4 minus 2t squared plus 2t minus 4, again over h. The fourth, well, we have a plus 4 and minus 4. We can just delete those two. We also have a plus 2t minus 2t. We can also just delete those two. And here I can see that I have a 2t squared and a minus 2t squared. Let's just delete that as well, so we don't have to keep dragging them. So we have 2, well, that's 2 times 2, so we have a 4th, then you have to multiply this as well, plus 2h squared, see, because that 2 was still multiplying that. Minus 2h over h. The good thing about this is that we have h in every single term, so we can just delete the h, this h, and this h. So here we get 4t plus 2h, because we had a h squared, we're just taking one h out of that term, and minus 2, because we don't have the h anymore. If we want to equal that h to 0, then we still get an equation here, right? Because that's the only term that goes to 0. Everything else is just 4t minus 2. That is my velocity equation. Let's see if we get the exact same thing by applying our original derivatives rule that we learned last time. X of t equals to my constant a times t to the power of m, then my prime, remember, of t equals to my a times my power n, and then we have t n minus 1. So we're going to do our prime. 2 times 2, because we're going to drop this here, 4t, and then 2 minus 1 is just 1. Then we have minus 2 times 1 is just 2. T minus 1 I mean is just 1, the constant 1, so you don't add the t. And every constant is just 0. So yes, we got the exact same, see, we got the exact same formula as by getting my little h equal to 0, which is the difference in time there. So there you have it. The simple rules that we know now to derive formulas come from that long process that we just solved. So if in any case in an exam you do forget one of your formulas or how to solve for a derivative, you can always go back to the long method and solve limiting h to 0. You don't have to do that if you know the formulas, because they all give you the same answer. If you have any questions, please just let me know.